Hello, I'm Justine Murphy with Laser Focus World. Let's take a look at some of the amazing things happening in photonics. With an ever-increasing global population comes our ever-increasing consumption of Earth's natural resources. Scientists are exploring regions worldwide for potential solutions, including in our oceans, and they found that a new light-based underwater system could help. A team led by researchers at the National University of Defense Technology in China has developed a light perception-based underwater digital twin interactive control system that can navigate the ocean's complex environment. Unlike conventional robotic hands that are too rigid and flexibility limited, the new system can perform delicate underwater tasks thanks to a multi-degree of freedom biomimetic pneumatic soft robotic hand equipped with a fiber Bragg grading sensor-based data glove that can be worn by the human user and the robotic hand. The team says this light filling the role of information carrier within the glove allows robust interactive control in replicating typical human hand gestures. And via the system's digital twin technology, essentially a live virtual copy of an actual physical object, it can synchronize movements in real time and produce bidirectional feedback. The team is now exploring brain-computer interface control to advance the system's operational capability and intelligence in extreme deep-sea environments. With eyes on a rapid growth strategy, Block Engineering is bolstering its executive team. The quantum cascade laser-based product manufacturer has named Dr. Denzel Vaughn its new Chief Operating Officer. A former vice president and general manager overseeing groups at Thermo Fisher Scientific, he comes to Block with years of experience in the mid-infrared spectroscopy market, as well as in commercializing and growing analytical instruments. Block representatives say Dr. Vaughn will help drive the company's next phase of growth. Elsewhere in the quantum sector, ZuriQ, a Swiss quantum computing spinout of ETH Zurich, has secured $25.5 million to ultimately scale its 2D quantum design. Described as groundbreaking, the new architecture involves processors that are natively two-dimensional. The approach uses a static magnetic field rather than the conventional rapidly oscillating fields, allowing ions to move freely without inherent constraints. Company representatives say this seed funding, led by technology venture capital firm Quantonation, will expand its research and development work and grow its team. Scientists have long thought that achieving true photon quantum entanglement was only possible with coherent light, like what's produced by high-energy lasers. But new research is upending that belief via a more energy-efficient alternative. Researchers led by a team at the University of Ottawa in Canada have demonstrated that natural light sources, namely sunlight, can just as effectively generate quantum entanglement, a phenomenon that's crucial for secure quantum applications like communications and computing. The new research involves spontaneous parametric down conversion, which creates quantum entanglement via the interaction between a nonlinear crystal and a laser-based pump beam. The team instead used highly polarized sunlight to prompt that interaction. In a series of experiments, and while accounting for differences in the input light's bandwidth, the entanglement generated from sunlight was about 94% identical to a perfectly entangled quantum state. The team says this approach could allow scaling of quantum technologies much more efficiently than is currently possible. They're now working to enhance brightness and the quality of entanglement to ultimately create a field-deployable system. And that's your Photonics Hot List. Be sure to like and share, subscribe to our YouTube channel, follow us on social media, and visit laserfocusworld.com for the latest and coolest news and information. Check out our Following the Photons podcast, too, for some cool interviews and news impacting the industry. Until next time.